Hello everyone. In this video we're going to be solving an inequality with a parameter. Or you can call this a parametric inequality. Now parametric inequalities are fun, just like parametric equations, but actually they're even more fun because the solution methods are more complicated. Now what this means is that for particular values of a, you get a different inequality every time. So for example, if a is equal to 5, you get the 5x over x minus 1 greater than 1, and it has a solution set. If a is equal to -4, then you just get a different inequality. And every time you're going to get a different solution set, obviously. But our goal is to find this in the general sense for different values of a. All right, let's get started. Now, what are we going to do first? First of all, we're going to take our expression and simplify it. And obviously, if you're solving an inequality, this is a rational type. So we have a numerator and a denominator. One of the things that you don't want to do, maybe I'll start with the don't do's. One of the things that you want to do is multiply both sides by x minus 1, because you have no guarantee that x minus 1 is going to be a positive quantity. It could be 0, it could be negative, so on and so forth. So what we're going to do though is going to be safer. We're going to subtract 1 from both sides. So let's go ahead and get started. So the first thing I'm going to do is subtract 1 from both sides. Now this way, I'll be getting a 0 on one side of the inequality, which is what we want. And then you'll make a common denominator. You know the drill, right? ax minus x plus 1 over x minus 1. You want this to be greater than 0. And then if you simplify this a little bit more. Now our goal is to find the critical values, in other words. So what makes the numerator 0? What makes the denominator 0? What are the boundaries? You know, what are the roots? In other words, what are the solutions that will make the sign changes? So in this case, then we can just go ahead and take out the a minus 1 times x plus 1 over x minus 1. So here we do see that two solutions arise. One of them is obviously the bottom, x equals 1. I'm not saying that x should equal 1. It can't. But x equals 1 is going to make a difference, because in this case, forget about the top. If x is greater than 1, the bottom is going to be positive. If x is less than 1, it's going to be a negative quantity. So it'll make a difference. So this is what I'd like to do then. Just announce that, okay, we have two solutions to this, and those are x equals 1 and x equals what? Now, we're going to find the second solution, right? We don't know what it is. How do you find it? Well, it's easy. You just solve this equation as a linear. So set it equal to 0 and solve for x. That's what you got to do. So if you do that, you're going to notice that you get something like this. And then I'd like to write it as -1 over a minus 1, but instead of writing it negative something, I want to keep it positive, so multiply both the top and the bottom, and I should be getting something like this. So my second solution is going to be x equals 1 over 1 minus a. So I'd like to circle those because those are my critical values, and of course, they make a huge difference in the solution. All right? So let's see how we're going to proceed from this point on. So this is the first part, finding the roots. And my expression, if you remember, going back to what we did first, my expression is a minus 1 times the quantity a minus 1 times x plus 1 divided by x minus 1. And I want this to be greater than 0, which means positive. Let's call this expression f of x, because I'm going to use that a lot when I'm solving this inequality. So instead of writing the whole thing, I'm just going to write f of x every time. Okay, now, so f of x represents the inequality that we're trying to solve for, or whatever needs to be greater than 0. So, having said that, now one of the challenges for solving inequalities is we're going to make a table, right? We're going to use the number line. We're going to use where this expression becomes positive, where the expression becomes negative, so on and so forth, where the sign changes, in other words. But one of the things that you don't know at this point is when I put these numbers on the number line, 1 and 1 over -1, let's say I'm going to make a number line, okay? I'd like to put these numbers, I'd like to order these numbers, but do you know which one is greater than which one? We don't, because depending on the values of a, 1 could be greater than 1 over 1 minus a, or it could be less. So that's what we're going to do next. So the next thing we're going to do is we're going to look at different cases here. So the first case, okay, can 1 over 1 minus a be less than 1? So my goal is to compare these two numbers, right? Those are my solutions. Those are my roots. Those are critical values. So how do you compare them? Let's go ahead and solve this as another inequality. So it's kind of like an inequality within an inequality. That's what makes these parametric inequalities so much fun. I hope you agree with me on that. Okay, so now what I'd like to do here is pretty much the same thing. Put the one on the other side. To keep a long story short, I'm going to give you the solution here real quick. So this is what we get after, subtracting 1, making a common denominator, so on and so forth. Now, obviously, we can solve this as an inequality by making a table, right? And on this table, obviously, we have two critical values. So we're looking at the critical values of the critical values here. So don't get confused. We're just solving this inequality here. And the critical values are 1 and 0. So we're going to place the 1 and 0 here. And this is going to be a. And if you want to call this expression g of a, whatever, that goes in here. So a over 1 minus a goes here on our table. Simple, right? Okay, so these are the roots. So this represents the positive infinity. This is the negative infinity. So, the numbers are going to get smaller, and then they're going to get larger as you go to the right. So what happens here is that you have to look at the sign here. We have a negative a, which is going to change the whole picture because we have to start with the minus sign. Again, I'm going to skip the details. These should be basic to you. If not, please let me know in the comment section, and I'll explain a little bit more. So now then we have a positive because if a is less than 1, then we're going to start getting positive values, and then it's going to change again at 0 because if a is less than 0, the bottom is positive when the top is negative. All right, cool. So this expression becomes, and I want it to be negative, right? This expression becomes negative here and here. So in other words, if, and I'm going to write this as an if statement, and that's important because at the end, when we put this all together, those if statements are going to be super duper important. So pay attention to those. Okay, great. So now if a is less than 0 or a is greater than 1, then we have 1 over 1 minus a being less than 1. And that comes from here. And that comes from here. Okay? Remember, we solved an inequality. In order for this to happen, what needs to happen? If a is like that, then this is going to be true. So what is that supposed to mean? Well, it means that we're going to look at two cases here. Now, why two cases? We can't put it all together because on one side a is negative here, and here a values are positive. And that does make a difference because if you look at our original expression, which is f of x here, I got to know if a is less than 0 or greater than 1. For example, if a is less than 0, then we're going to get a negative quantity here. Minus 1 is going to keep it negative. And the sign is going to be different. The table is going to be different. So we're going to make two tables. So I'm going to say, okay, if a is less than 0, maybe I'll just branch off like this. Now let me call that a. If a is less than 0, then I have the following. Okay, I have the following table. I'm going to make a table here, but this time the table is for x and f of x. So we're basically going into the solutions here. Make sense? Okay. So now we know that if a is less than 0, I know that this will be satisfied for sure. So when I make my table, I'm going to put the 1 over 1 minus a to the left of 1 because I know that it's the lesser value. Now, what about the sign at positive infinity and the sign at negative infinity? Well, it's going to be determined by the expression of f of x. If you look at f of x, a is less than 0. So we got a negative expression here, but this is a positive expression here. So their product we're going to look at is going to be negative. So we have to start with a minus sign here. That's super important because if you mess it up, then the whole thing will be messed up. And then of course it's going to change and it's going to change again. Now, what am I looking for? Well, I do want my f of x value to be greater than 0. So I'm basically looking for positive f values, which are going to happen here. What is that supposed to mean? It means that if a is less than 0, then our x values are going to be in this interval. And what we're going to do at the end is we're going to go back and put it all together. But let me go ahead and look at the second case scenario. And the second case scenario is about what? Well, we said that if a is less than 0 or greater than 1, then this will be true. So now I got to look at if a is greater than 1, then I do get a slightly different table because even though the 1 over 1 minus a is still less than 1, I do start with a different sign here. Why? Because if you go back to f of x here, remember where we had the f of x, I have the a minus 1. It is greater than 1, so a minus 1 is going to be a positive, and the bottom one, x, is also positive. So their product is positive. So I'm going to start with a positive sign here this time. You see the difference? And this is going to be a negative, and this is going to be a positive again. So this means that since I'm looking for f of x values that are greater than 0, right here, f of x values need to be greater than 0, I'm looking for the positive values, just like the previous table. And so what it means is that if a is greater than 1, then x values must be in that interval in order for f of x to be greater than 0. You see how complicated that can get? Yep, it can get very messy if you're not organized. Okay, so we want f of x to be greater than 0. Therefore, our x values need to be in that interval if a is greater than 1. Of course, we have this conditional statement. All right, cool. So this is part of the problem or the solution. And now we're going to do the second piece, the second bullet point. So this was the first bullet point with 1 over 1 minus a being less than 1. Of course, we have to take the opposite of that. And now what if this value, because it doesn't have to be, right? What if this is greater than 1? And what if it's equal to 1? We're going to look at those particular cases, special cases later on. At the end, I'm going to put it all together. Okay? Now, if this is true, then let's see what happens. Obviously, you're going to be getting the same type of inequality, but this time, instead of being less than 0, it's going to be greater than 0. And you're going to make a table, just like before, just like this one here. Look at that. All right? You're going to put an a here. You're going to put the a over 1 minus a. And of course, the roots are 0 and 1. They are already arranged, so we don't have to worry about it because they're not parameters. Now, the general sign, again, is going to be negative. No difference, no difference. But the only difference is that this time we want the g of a, maybe I'll call this expression here, g of a. We want this to be positive. Last time we wanted it to be negative. So since you want that to be positive, you're basically looking at a different interval here. This is the interval you're looking at. Now, what is that supposed to mean? Well, it means that if a is between 0 and 1, okay, let's write it down. If a is between 0 and 1, then you're going to have 1 over 1 minus a greater than 1. All right, cool. That's my second thing. Look at the first one. If a is less than 0 or greater than 1, this will be satisfied if I don't want to say otherwise because 0 and 1 are not included here, but if a is between 0 and 1, then this will be satisfied. And again, since this is satisfied, I just need to make a table accordingly, right? Remember in our previous expression, we had two different pieces, but here we don't have that, we only have one. So what are we going to do? We're just going to say, okay, if a is between 0 and 1, what happens? Let's go ahead and take a look at it. And of course, I'm going to make my table here right away. And since 1 over 1 minus a is greater than 1, I have to write the 1 first to the left of 1 over 1 minus a. Notice that we're getting a different table here. And I can put f of x here. Now what's going to happen is that if you go back to f of x, or maybe I'll just write it down here for your reference, f of x is equal to a minus 1, the quantity a minus 1 times x plus 1 over x minus 1. And you want that quantity to be greater than 0 all the time. That's not changing, okay? But if you look at the sign changes, a is less than 1. So this gives us a negative quantity here. The coefficient of x is negative. The coefficient of x is positive. Their product is negative. The general sign has to be negative here. So if you go back and check the other situations where we had two different scenarios, they were different because of the different values of a. Okay, here we only have one table. And of course, it's going to change like minus, plus, minus, plus. Okay, so that's my table for the second bullet point, which requires that 1 over 1 minus a is greater than 1. And that happens when a is between 0 and 1. All right? And in this case, of course, we're going to get the solutions here because we wanted this f of x to be greater than 0, and this is f of x, and we want f of x to be positive. Therefore, the x values are going to be between 1 and 1 over 1 minus a. Okay, so all these intervals that I shaded are solutions. For example, here in A, maybe I can call this C, even though it's not part of something, we didn't have two branches here. So if you look at this one, and then this one, let's just put a C here maybe. Okay, if you look at three scenarios here, the parts that I underlined are solutions. So what I'm going to do now is I'm going to write the solutions all together as one piece. Putting this all together, okay? All right, cool. Now, since I'm looking for a solution set, I'm just going to do my curly braces and write all the different cases. So, the first case, if a is less than 0, then my x values are going to be between 1 over 1 minus a and 1. Now, where do we get that? If you go back here, this is where I get it. If a is less than 0, then my x values have to be between 1 over 1 minus a and 1 in order for f of x to be greater than 0. Remember, that was our goal, to make the f of x greater than 0. All right, so basically I'm just gonna take all these solutions and put them together. If a is less than 0, and then x needs to be in this interval. If, on the other hand, if a is greater than 1, remember they came together, then we have a different table, therefore the solution is going to be different, but the solution has two pieces, so I'm going to write it as x is less than 1 over a, or x is greater than 1. Again, that comes from the b part. Notice that we have two different pieces here. Okay? Now the next part, the next thing I'm going to look at is the last piece of the solution, pretty much from here. Remember the c part. We said that if a is between 0 and 1, then we're going to get the solution in this interval. So let's go ahead and write it down. So if a is between 0 and 1, then x is going to be between 1 and 1 over 1 minus a. Notice that the value of 1 over 1 minus a is changing. That's why our inequalities are also changing depending on the values of a. Okay, did I cover everything? No, because now we have to look at some special scenarios. And let me go ahead and write down f of x one more time for you to reference. F of x is equal to the quantity a minus 1 times x plus 1 divided by x minus 1. And remember that we want this quantity to be greater than 0. Okay, cool. Now, what are some of the a values that we didn't consider? Obviously, the boundaries. For example, what happens if a is equal to 0? Now, that's kind of interesting, and it's easy to check because it's a particular value. It's not an inequality, and that's fairly easy. You can just substitute. What happens if I replace x with 0, right? I mean, if you replace x, or did I say x with 0? I meant a with 0. Okay. Well, if a is 0, this is something interesting happens. So you're going to replace a with 0 here. You're going to get negative x plus 1 over x minus 1. And that is actually equal to negative times x minus 1 divided by x minus 1. And if x equals 1, we have no solution. And if x does not equal 1, then these two cancel out, leaving us with negative 1. Is negative 1 greater than 0? That's false. Now, this collapses. But if you look at the original problem, forget about f of x and just check the original. Remember, our original inequality was this one. And if you check it out on the original one, you'll see better. If a is equal to 0, then you'll get something like 0 is greater than 1. Again, something that is false. So this means that if a is equal to 0, then we have no solution. Okay? Let's go ahead and emphasize that. We have no solution if a is equal to 0. Unfortunately, that's the only case basically. Okay? What about the a equals 1 value? Let's check it out. Well, you can again replace a with 1. If you do it here, it's going to be a little harder. If you do it here, it's going to be a little easier because 1 minus 1 is going to be 0. So if a is equal to 1, you're going to be getting something like 1 over x minus 1 is greater than 0. And this is only true if x is greater than 1. So if a is equal to 1, then our solution set is going to be like this. Then x is going to be greater than 1. All right? So that pretty much brings us to the end of this video. Thank you for watching. I hope you enjoyed the video. Please let me know, comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.